Hello, welcome to our final design presentation for the virtual internship in biomedical engineering at WPI. Our project is called Sterile Spotlight. I'm Casey Healy from San Jose State University.
Hello, my name is Jasmine Bogle, and I am a rising senior attending the University of Massachusetts Amherst.
I'm Mia Velletri from Worcester Polytechnic Institute.
We decided to focus on the Republic of the Congo. This country in sub-Saharan Africa is ranked 156 in the world for maternal mortality. Women giving birth here face numerous challenges. Over half of the country's population does not have access to electricity or filtered water. This has contributed to widespread poor sterilization techniques, which can be especially dangerous when sanitizing the equipment used in childbirth and cesarean sections. Compounding this risk is the fact that the majority of the births in the rural areas of the Republic of the Congo occur at home, rather than at the country's hospitals, where more advanced sanitization techniques are in place. We revised our client statement to take into account these challenges and the specific needs of the region. We then set out to propose a sterilizer for childbirth surgical equipment, specifically those used during cesarean sections. Our design needed to account for the challenges the Republic of the Congo faces in terms of accessing electricity and filtered water. We also want our design to be intuitive, portable, and accessible.
Now that we have discussed the theory behind our design concept, this is our practical application. Demonstrated here is our UV light sterilizing system we modeled in SolidWorks. Here is our sterilizer powered by two UV light bulbs housed in a secure metal box. On the side, you can see the battery pack that will power the UV light sanitation. This is a crucial part of our design as the majority of the Republic of Congo does not have access to electricity. Battery operation will allow for midwives who travel to remote areas to have a reliable method of sterilizing the instruments required during C-sections should emergent situations occur. This is also why we have included an optional folding and mobile table for the system to be mounted on. The dimensions of our design is 11 inches in terms of length, width, and height, and would approximately weigh 10 pounds when not in use. To get an idea of the types of tools that are required during these procedures, you can see that they are relatively small and consist of needle drivers, forceps, and a series of clamps. UVC light has been shown to break down the molecular bonds of viruses and bacteria's DNA. When applied to surgical equipment, UV light is an effective method of sterilization and is less expensive than most other hospital methods. Since UV sterilization uses the energy of UVC to destroy biomolecules, its effectiveness depends on the total energy applied, which is affected by the length of exposure, time, and the distance from the light source, which is why our design includes a control panel with a variety of settings. Instruments would be placed onto the metal tray, the door would be closed, and the desired cycle of sterilization would begin.
In order to better understand the simplicity of our design, I will be doing a quick demonstration with a pair of needle drivers. If you are a midwife intending to sterilize these needle drivers using our UV light sterilization box, you would place all instruments on the metal removable tray, close the door, and choose the intended cycle that you would like all instruments to run on. And to ensure that the tools would stay sterile until their intended use, all tools would be placed in airtight bags that would allow them to remain decontaminated and dry until needed.
Thank you for watching our presentation.